So our sun is this absolute powerhouse, right? It's got this massive magnetic engine inside. But here's the crazy part. For almost 50 years, our best models, our best science, predicted that this engine should have just broken down. It should have completely stalled. So what's going on? What's kept it running all this time? Well, today, we're going to dig into a brand new discovery that finally cracks this solar mystery wide open.
All right, let's really get into this, because it's a big deal. You know, the sun's magnetic engine, it's the reason for everything from those incredible northern lights to, well, really dangerous solar flares. And yet, for decades, the models we built, the physics we thought we knew, all pointed to one thing: it shouldn't work. The whole system should just stop. So the big question has always been, why hasn't it?
Okay, so to really wrap our heads around this, we've got to understand the engine itself. We're going to take a trip deep, deep inside the sun's super turbulent core to see exactly how it creates that amazing magnetic field. So the big idea here is something called the solar dynamo. The easiest way to think about it is like a giant cosmic power plant. You've got all this superheated gas, this plasma, just churning and rotating deep inside the sun. And all that motion, well, the dynamo converts that raw kinetic energy into magnetic energy. And it's this dynamo that's responsible for the sun's entire 11-year cycle. But there was a problem with this engine, a huge one. And scientists, they love a dramatic name. They called it catastrophic quenching. And believe me, this has been a major headache for astrophysicists for a very long time. And here's the thing that's just wild. Scientists knew something was missing in their models. The math just wasn't matching reality. I mean, the equations predicted this total system failure, but, you can look outside. The sun is still there. It just keeps on going. So there was a huge piece of the puzzle missing.
Okay, so let's break down how the old model was supposed to work and then fail. So, step 1, the sun spinning stretches out its magnetic fields north to south. Then you've got convection. That's just the boiling motion of all that plasma, and that twists the fields back around. Simple enough, right? That cycle creates the magnetic field. But here's the catch. This whole process creates a nasty byproduct, a kind of magnetic waste. And according to the models, this waste just builds up and up until it literally chokes the engine, causing the whole dynamo to just stall. And that's catastrophic quenching.
So, this magnetic waste, what is it really? Well, let's give it its proper name. The culprit at the center of this whole thing is called magnetic helicity. Sounds cool, right? Basically, magnetic helicity is just a fancy way of saying how twisty a magnetic field is. And the problem was, in the old models, the dynamo was making the wrong kind of twistiness. It was creating this tangled mess of tiny magnetic fields that were actually fighting against the big, powerful field the sun needs. The engine smoke analogy is perfect here. A little smoke is fine, but if you don't have an exhaust pipe, it's just going to fill the garage and the engine will die. That's what was happening here. And listen, this isn't some new problem they just discovered. Get this quote comes from a paper way back in 1975. So for nearly half a century, physicists have known about this fundamental problem, that this small-scale magnetic gunk was actively working against the very thing that was supposed to keep the sun's engine running. But now we have a solution. A brand new paper has just come out with a stunning answer. And it's not just some tiny little fix. Nope. It's a whole new part of the solar engine that we'd been missing. And it's called the NV Flux. Seriously, this is a total game changer. This new research, it suggests we found a mechanism that doesn't just get rid of the smoke, it actually takes that waste energy and uses it to supercharge the entire system. So it's not an exhaust pipe, it's a turbocharger. So what exactly is this NV flux? Well, it all comes down to the sun's powerful rotation and shear. This spinning creates a kind of giant cosmic whirlpool. And this whirlpool grabs all that messy, tangled-up magnetic waste, and it smooths it out, creating the perfect kind of twistiness that the dynamo needs to get supercharged. And check this out. This image from the paper pinpoints exactly where this action is. See those really intense red and blue zones? That's it. That's the powerful shearing, the vorticity. That's the key ingredient for the NV flux. This is the hidden power source we've been looking for. Okay, so this is the moment of truth. What happens when you actually add this new ingredient to the computer models? Let's put them side by side, because when you see this, the solution just becomes undeniable. All right, have a look. On the left, that's the solar cycle from the old model. I mean, it kind of works, but it's pretty weak, right? Now, look at the right. That's the new model with the NV flux added in. Wow,
The difference is just night and day. The whole cycle is stronger, it's more stable, and it just keeps going powerfully. The engine isn't choking anymore, it's absolutely thriving.
Let's switch views here and look at a snapshot of the magnetic fields themselves. Again, old model on the left, new on the right. Now, zero in on the poles, the very top and bottom of the sun on the right. See those really bright, intense bands of color? That's showing us a way stronger magnetic field at the poles. And that is the #1 sign of a healthy, powerful solar dynamo.
And hey, we don't have to just go by the pictures. The paper lays out the cold, hard numbers. This table compares the actual strength of that polar field. In the old model, M0, it tops out around 30 Gauss. Okay, but in the new model, M2, with the NV flux, it hits 60 Gauss, a huge jump.
That's right. It's literally twice as strong. This isn't some tiny adjustment. This is a massive power boost. It proves, without a doubt, that the NV flux solves the catastrophic quenching problem. The engine has officially been turbocharged.
So, look, solving a 50-year-old physics puzzle is awesome, for sure. But you might be wondering, why does this matter to me here on Earth? Well, it turns out understanding our sun's engine has some really big real-world implications.
I mean, for starters, it finally puts to bed a mystery that's been bugging scientists for half a century. That's huge. But on a more practical level, this means we can build way more realistic models of the sun. And that helps us get better at predicting space weather. Things like solar flares that can mess with our satellites and even knock out power grids. And it goes beyond our sun. Since other stars have similar engines, this helps us understand how stars work all across the cosmos.
So, think about it. We were so sure we understood the sun's engine, but there was this massive piece of the puzzle hiding right there, in its own spin. It really makes you wonder, doesn't it? What other huge cosmic secrets are out there, just waiting for us to find them, by looking just a little bit closer at the things we think we already have figured out?